Thank you, Dylan, for your warm introduction, and also thank you, Willy, for your hour-long introduction for my talk. I'm going to be benefiting from yours. So I'm Jeremy, I'm CTO at Evolix, and we do a lot of hosting and services and server management, and we use exclusively open source software. I'm here to tell you today how we have combined HAProxy and Varnish together to make a CDN-like service that we call Boost, hence the name, the word. Its goal is to accelerate web services for our clients and for our internal use. It's been in production for many years, and I'll show you what it is today. I will keep a good pace during the presentation, but we should have plenty of time for questions at the end. And everything is already available at this URL. It's a Git repository with the slides, diagrams, and all the source code and configuration. So let me tell you why we chose HAProxy and Varnish in the first place. They are both free, libre, open source software, which is very important for us. And even if we use mainly Debian servers, the fact that they run on many different platforms is a very, very good thing. They are both designed to be very efficient with resources, very stable. HAProxy was created in 2001 and Varnish like 2006, so they are battle-tested software that you can rely on. They have great documentation online and offline, and vibrant communities, and the fact that we're here today to enjoy this. And if that is important for you, both software have companies behind them, and you can subscribe for commercial support if you need it. Let's have a closer look at HAProxy itself. So it's a proxy, and it sits between the clients and the server. Its goal is to provide high availability for web services. And the two main concepts that are important for us today are the front end and the back end. The front end is your entry point. That's where the clients connect. And the back end are the exit points where we connect to the final application servers. And with this and all the features of HAProxy, we can implement some load balancing and fault tolerance strategies for attaining high availability. Varnish works like the cache in your web browser, but it's way more powerful and way more configurable. Its goal is to accelerate web services by catching some requests and responses to return them directly to the clients on subsequent calls, thus drastically reducing the overall response time of your application or your web service. It exposes its configuration as predefined subroutines like functions written in VCL. It's a domain-specific language, and they implement very good default configuration that you can use right out of the box, but also that you can extend or completely override if you need for fine-tuning. And the final configuration gets compiled at startup for maximum performance. Even if it's really, really big, it is compiled. Varnish shares the same concept as HAProxy with the front end, with the VCL receive and VCL deliver subroutines on the left for the clients. The VCL backend fetch and VCL backend response are the backend side with the servers. And in the middle, we have the main part, the most important one, the cache. It's usually done in memory, and that's where Varnish stores its object for reuse. So how did we combine HAProxy and Varnish to make Boost, our CDN-like service? This is the overview, an oval diagram. The clients enter the system at the HAProxy level on a front end that we have called external. This one does all the heavy lifting on the HTTP part, like TLS offloading, redirects, sometimes authentication. Everything that we can do very early, we do at this level on the external front end. Then if the request can be sent to Varnish, if it's cacheable and if Varnish is available, then we use a special backend that we have called Varnish for simplicity. And since Varnish and HAProxy are on the same server, in our situation, we use Unix domain socket for simplicity and performance too. Varnish, when it receives the request, will look at the cache. Is there something available? If so, we can serve it directly to the client without going any further. And if it's not, we can go further down the line through the backend section and back to HAProxy. But this time we use a second, another frontend that we have called internal. This one is much simpler than the first one because there is no offloading, no header manipulation. We just need to differentiate a request for site A, site B, site C, or another web service, and use the proper backend. And the backend will connect to the final server that will process the request, prepare the response, which will go all the way back to the client in reverse. And if it went through Varnish, it will try to cache the response if it's cacheable. That was a very broad overview of the setup. I will zoom in on a few specific features that I think are interesting. The first one is that we are able to deal with many different websites and not only one per instance. And even if we don't have the concept of a virtual host like we have in Apache or Nginx, we can implement this very simply in HAProxy and Varnish. We have a look at the host HTTP header, and for each domain that we know, we can store the yes or no value, the true or false value in an ACL, which is a Boolean variable. And later on, we can use the proper backend depending on the domain that is in the request. And then we have a backend for each website or web app and use the proper balancing or the proper servers, one or many. To decide if we pass the request to Varnish, we need to know if it is available. Otherwise, we are going to have 503 errors that we don't want. And with an HTTP check from the Varnish backend, we can ask if Varnish is available. And on a very simple request, Varnish can reply very quickly in the VCL receive subroutine to say, yes, HAProxy, I'm fine, I'm available, you can send me some traffic. So HAProxy will send the request to Varnish, but if it's not available, then we do not want to send errors, so we can go directly to the proper backend. It will probably be slower because there is no cache, but we won't have errors. Sometimes there are other reasons for which we do not want to send the request to Varnish. Let's say we need to use the HAProxy features, but we do not want the cache. For example, if a website is completely customized per user, there is no sense in going through Varnish. So if the host header says this site, we can bypass Varnish. If we manage lists of domains where the caching makes sense or not, we can have a list in a file and tell HAProxy to have a look at this file. And we can even manage this list externally from HAProxy and just ask him to reload the list and decide if the request needs to go to Varnish or not. And some requests, some HTTP requests make sense for caching, some don't. A get or head or a purge request should go through Varnish, but a post or a put don't make sense, even if Varnish will do the same work, but if we can bypass it completely earlier, then it's better. And of course, we can combine all those ACL and conditions to only send the request to Varnish if it is available, if the domain should be cached, and if the HTTP method is eligible for cache. The proxy protocol helps us with a very common problem when we deal with proxies, and especially multiple proxies in a chain, that is keeping track of the original client IP address. This is a typical situation. We have our clients. It connects to our Boost server at the external front end of HAProxy, which sees the correct client IP address. But when HAProxy connects to Varnish, Varnish sees HAProxy's address and not the client's. And next in the line, and finally, when the Boost server sends the request to the final application server, it sees the Boost proxy IP address and not the client's one. This is very bad because in each log file, you will see only one IP address. You are not able to do some distinctions like authentication or filtering. That's very bad. Sure, there is a response, a solution in the, at the HTTP level, the application level. That is the X-forwarded for header, in which we can append IP addresses at each step in the process. But it's cumbersome, it's error-prone. If you misuse it, you're going to have problems down the line. So that's why the HAProxy team introduced the proxy protocol in 2010 to fix this at the TCP level directly. The downside is that both sides of a connection with the proxy protocol enabled should support it, otherwise it doesn't work. But a lot of software supports this protocol now. Obviously, HAProxy and Varnish, but also Apache, Nginx, a lot of web servers, a lot of HTTP clients, and even some non-web related software like Dovecot or Postfix, and much more every time. So this is a situation where we use the proxy protocol inside our Boost proxy and also to the final application server. And as soon as it is enabled, there is nothing else to do at the application level, the HTTP level. It's done automatically. So how are we going to configure this? Very easy. It starts at the Varnish backend level. We add the send proxy v2 option on the server definition. When we start Varnish at the command line, we need to add the proxy option on the listening interface. In its backend section, we add the proxy header equals 1. And in the internal front end of HAProxy, we need to accept proxy on the bind definition. And if we can go all the way to the final application server with the proxy protocol, we also need to add the send proxy v2 on the server or the server's line in the backend for this website or this domain. This is very easy. The proxy protocol is really good, but there is a downside. You cannot use raw HTTP request to a listening interface that is supposed to receive a proxy protocol connection. So you cannot send easily telnet request, HTTP request through telnet. So there is a very simple solution that is adding a secondary listening interface to Varnish without the proxy protocol. We can use a local IP address. And with this, we can bypass the first step of HAProxy because it's quite complicated and it does a lot to the request. If you want to try directly on the Varnish server, then you can do this like this. And then you can use anything you are used to connect to your web server. This is an example with curl without the proxy protocol, because yes, curl supports the proxy protocol with a simple proxy header option, but it's just an example to show that you can do it manually. It's possible to go all the way to the final application server with the proxy protocol, and it really simplifies the way we deal with the client IP address. But if you do, you may have the same need as we've just had with Varnish, that is to connect directly to the final application server. So you could do the same trick and as in your Apache or Nginx configuration, a secondary non-proxy interface and use it. And here's a pro tip. If you're using Apache, you should use and enable the forensic log module. It will give you a special log file with each request and every HTTP header from the request right in the log file. That is really, really useful for debugging. And since we are talking about HTTP headers, as you probably know, there are some standard headers. On the request, for example, we have the host, user agent, accept, cookies, and many of them on the response too. But we are not limited to this list of HTTP headers. We can have custom ones. They just have to begin with an X dash, and you can do whatever you want. And we do this extensively within our Boost configuration, and I will show you how. Even if we use the proxy protocol as much as possible, sometimes we can't control the configuration on the final servers. So we keep the X forwarded for header that we have seen before. And it's so common in HA proxy that we have a forward for option to do this automatically. We also add the X forwarded port, with the destination port of the client, and the X forwarded proto with the value of HTTP or HTTPS to inform the server whether the client connected over HTTPS or HTTP. We also mark every incoming request on the external front end with a unique ID using the UUID function in HA proxy. And this is useful to have this unique ID in each log. And bonus point, if you are the final application is also returning this unique ID in the response, then the client can see the ID, and it makes debugging very, very easy because you find the ID in every log file. As far as I know, there is no consensus on the header name. I've used X unique ID. I think it's from the HA proxy documentation, but you can find X request ID too, or some other variations. As you've seen on the diagram, it's a three-step setup. Step 1 is the external front end of HA proxy. Step 2 is Varnish, and step 3 is the internal front end in HA proxy. And at each step, we add some headers on the request and then on the response. XBoost step 1, step 2, step 3, very easy. On the request, we add the name of the step, and on the response, also some information about the connection. Here on step 1, we inform the client that originally it made a connection over SSL or not. And if we have many Boost proxies available, then we also can add the host name of the server that has been used. Step 2 is Varnish. Very easy for the request. On the response, we also add some information, whether the final application server did or did not send some set cookies or cache control, because it will help the client understand why maybe Varnish did or did not cache the response, a hit or a miss. Is it cacheable or not cacheable? It helps understanding without having to go to the server and see the configuration, etc. Third step is very similar to the first. Its name is HA proxy internal, and this time we say SSL backend or no SSL backend, depending on the connection to the final application server. So the client will have a lot of information about how its request was processed, where did it go, how did it come back. And if you want to turn the debug level to 11, you can also do this sorcery. You can put the whole HA proxy log in a response header. That is crazy, but that is really useful for debugging. I suggest you do not do this in production, since you will leak information that could be harmful. But on a debugging server, on very specific situation, it gives a lot of power to the client, because it doesn't have to go to the log files on HA proxy. It sees everything directly in its response. This part is very common, so I will not go into much details, but on the external front end of HAProxy, we can do a lot of manipulations, very standard, very common. But let's say we have a blacklist of IP addresses that we want to reject right at the transport layer. Very easy to do. That's not a replacement for a real firewall, but it's easy to do this in HAProxy. You can change the list dynamically, and it's very responsive. You can also do the usual suspects like HTTP basic authentication, redirects from HTTP to HTTPS, redirects from one domain to the other, or anything you would like to do on the request. We have implemented what we call the maintenance mode, because it's a kind of circuit breaker. And in case of an incident or a scheduled maintenance, you might want to stop all the requests at the entrance and reply to everyone with the same very quick and very optimized response with the 503 return code. That is really easy to implement. You just set an SCL, is it enabled or not? And if it is, you use the maintenance backend, which has no server defined. So each request will trigger a 503 error. And with a custom file, it can be returned directly. And if you want to give your sysadmin or developers team a way to bypass this maintenance mode, this blockage, and go to the backend, you can use a whitelist of IP addresses. And that way they can verify that after the incident or after the deployment or after the maintenance, everything is working correctly before you can open back again to the general public. This is done globally, but we can also do it per site using the same ACL that we've seen before. And that way we can have also the specific whitelist for this domain, a specific error page for this domain. Very easy to do and very basic. And previously I've mentioned HTTP methods and I've mentioned the purge method. This one is not standard per se, but it's very common when we use caching proxies. It's useful to tell Varnish to remove some objects from its cache. In this snippet of code, we are in the VCL receive subroutine. It's right at the beginning of the request cycle in Varnish. We can verify that it's for a specific domain, that it is a purge request, and that our IP address is in a whitelist. You don't want everyone to be able to empty your cache. But if those conditions are met, then we can purge either everything or just specific addresses, specific objects. That's really useful to give this power to the client to tweak or to invalidate some cache. Our Boost proxy is a proxy, but nothing prevents us from having some services locally. For example, if you manage ACME challenges for Let's Encrypt certificates, you might want to have a specific backend for Let's Encrypt, a specific ACL on the path, and you can do this right at the Boost proxy level. You can have some meaning graphs on HTML pages that you want to be able to consult. Also create an ACL and a backend, very easy, very simple. And let me address the big high availability elephant in the room. On the application level, this is done by the application itself. It's not our job, but if they provide us many different servers, we want to exploit the features of HAProxy to do that. I will not go into details, but it's very common. But our proxy, our Boost proxy, must not be a single point of failure. Otherwise, it's stupid. The very simple solution that we chose for this is having the multiple Boost proxies in parallel. And we use some round-robin DNS to direct the clients to either one of the servers. This tolerates a failing data center or a failing network provider. We can disable a server at any time from the DNS zone. It's very easy. Of course, there is a downside. We have to go in the zone, change it, and the propagation time is not 0. So we might have a minute or two of downtime, but we use some virtual servers on high-quality, redundant hardware in tier 3 data centers with multiple network providers, so complete failure of a boost proxy is very, very rare. And if it happens, usually we have much bigger problems to deal with than a minute or two of downtime on this level. And we are currently testing a solution based on Anycast BGP and other solutions to even improve this part, but this is not finished yet. And you can go, if you want, all the way to this kind of design that I've shamelessly stolen from the HA proxy documentation. This is very good, but we found it too complex and too resource hungry for us. Our solution is much simpler, but this one is also very, very nice, and it's easy to implement with HA proxy. I've covered pretty much everything I wanted, but we have like 10 minutes for questions, so I'll be happy to answer as much as I can. Questions, critiques, maybe we have overlooked some features that are really useful and we don't know about, or maybe we have made some mistakes, but please hit me with questions.
So first of all, a big round of applause for Jeremy. Great job. So we will be taking questions. Just raise your hand nice and high. Our helpers here with the microphones will bring them around to you in the audience. For everyone on the stream, we are also taking questions in the stream. You can also send them on Twitter, #HAProxyConf. So we already did have a couple questions come in during the chat. If you think of your questions as we go here, just raise your hand. We'll bring the microphone around to you. OK, so the first question, for anyone who has not tried Varnish with HA Proxy, what would you recommend as the first step?
As I've said in almost the first slide, Varnish is available on many different platforms as packages most of the time, so it's very easy to install. The default configuration is good right out of the box, and it's easy to extend or change. The documentation, of course, is available, and I think it's very easy to try it and to add it in your infrastructure.
OK, we do have another online. So for anyone with a bad memory who may forget whether the load balancer goes in front or the cache goes in front, what do you tell them and why?
Yeah, I would tell them both, because we have put a front end of HA Proxy in front of Varnish and another front end from HA Proxy beyond Varnish. So it's kind of a sandwich situation, and Varnish is in the middle, because we preferred using the capabilities of HA Proxy regarding the load balancing strategies, the algorithm, etc. So we keep HA Proxy in front of the final servers. But we also want HA Proxy in front of Varnish to, in our opinion, more efficiently manage the HTTP part, the TLS offloading, etc. So we have both in our setup.
And I think we have a live question here.
Hi, thanks a lot for your presentation. I wanted to ask, you mentioned that you have lots of these boost proxies which have a proxy inside, right? And how do you manage all those HA proxies? As I understand, you don't have any control plane above this, right? And
yeah.
How do you do all this?
We deployed the configuration with Ansible. We currently have 2 or 3 boost proxies. They are configured exactly the same. And the change of configuration in our situation is not very frequent. Maybe once a week we have to change something. So firing an Ansible playbook is quite good for us. And we use a big template, both for Varnish and HA Proxy. The Ansible playbook will overwrite the configuration from the template and reload the processes. We do it one server at a time, in case we have a misconfiguration or something goes wrong and it doesn't crash everything.
And sorry, do you provide any SLAs for these boost proxies? And how you did that stuff? Like, do you have your own backends or what? SLA for Boost Proxy.
Yes, our work is to provide some services to our clients, either on their servers or on our servers. But yeah, this is concerned by our SLAs. Yeah.
We have another question here. And if you're in the back,
Hi.
raise your hand. Hi, we can't.
Thank you for your presentation. Do you share the content of Varnish between each other,
No.
or they are standalone?
For simplicity, we don't. But I don't know, maybe we could, but it's much more simpler to not have to deal with this. Both proxies are in different data centers, and having some synchronization would, I guess it's doable, but we didn't need to explore this. So it's separate. If your DNS resolution sent you on one, then the other, then the first one, then we have the same kind of situation that Willy mentioned before, but we lose some efficiency. But it doesn't really matter in our own situation.
You mentioned banning or purging cache in Varnish, and you have multiple instances of Varnish. How do you manage like synchronization? Because if you want to purge something, some URL, you need to do it across all the Varnishes. So
Yeah.
how do you do this?
Exactly. In some cases, we don't manage it. So it's a lack of features. But in fact, most of the time, we provide a very, very simple web interface to our clients. It's a simple PHP page. And they can select their own domains and click a button. And in this case, we send the request to both HA proxies. But if it's done from the client's perspective through an HTTP call, then it's only on one Varnish. That's something I think we need to address, and maybe we have overlooked.
Great. Well, Jeremy, thank you so much for your talk.
Thank
Really
you, everyone.
appreciate
Feel
it.
free to come see me and talk to me afterwards. Thank you.